Welcome to another class, another trigonometry class. Today we'll be discussing solving right-angled triangle. We've done series of questions on isosceles triangle. What's a right-angled triangle? A right-angled triangle is a triangle that has one of the three angles as 90 degrees. One of the three angles are 90 degrees. So it means that the other two angles sum up to 90 degrees. Let's look at this analogy. A triangle ABC is here. The side facing A, let's call it A. The side facing C, let's call it C. Side facing B is B. Now, these are the three sides. The longest side facing the right angle side is called the hypotenuse. B here is the hypotenuse. It's usually the longest side. While if we call this A angle, or let's say this is X, this is Y. Now for Y angle Y, the side facing Y, the angle Y, is called opposite. That's C. Opposite. C will be opposite. While the side adjacent to the angle Y, beside angle Y, is called hypotenuse. Adjacent rather. Adjacent. Any side facing the angle in consideration, opposite it's called opposite. While the other side that is not hypotenuse is called adjacent, and that adjacent is usually beside it, adjacent to the angle in consideration. Let's look at X, angle X. The opposite side to X will be A, while the adjacent to X will be C. Opposite, then adjacent. The hypotenuse is always constant. It's the longest side facing the right angle. The angle 90 degrees itself is always constant. But opposite, the side called opposite and the side called adjacent are changeable depending on the angle in question. Depending on the angle in question. Let's look at what we are trying to say. Like C here, the side C here is opposite to angle Y. But this side C is adjacent to angle X, as we have seen here. While the hypotenuse is always the same. Let's look at another factor before we start looking at questions. Another factor in right angle triangle. Another factor in right angle triangle is what we call complementary angles. Complementary. The sum total of angle in a triangle, the sum total of angles in a triangle are usually 180, the three, whatever kind of angles they have. Now, but in a right angle triangle, one of the angle is already 90 degrees. It means the remaining two will sum up. The remaining two will sum up to 90 degrees. Looking at this earlier triangle, we said this is X and this is Y. X plus Y plus this 90 degrees will give us 180 degrees. It means that X plus Y will give us 90 degrees. How? X plus Y will be 180 degrees minus 90, which is this. So X plus Y equals 90 degrees. Now, these X plus Y are complementary angles. This is already 90. So if we call this, for instance, Y, it means X will be 90 minus Y. Y will be the same thing as 90 minus X. complementary angle. So these two angles are complementary. They must sum up to 90 degrees. Let's give an analogy. Let's assume this is angle theta. It means this one will be 90 minus theta. Because these two sums, 90 minus theta, which is an angle itself, plus theta, will give us 90 degrees. Because this is already 90 degrees. So let's open the bracket. 90 degrees minus theta plus theta equals 90. These will cross themselves out, and we have 90 degrees. So these are what we call complementary angles in right angle triangle. Let's look at some questions to buttress all what we are trying to say. Let's look at this triangle. Let me draw a straight line. Then I have something like this. This is a right angle triangle. Then we have a straight line. This is another right angle triangle. Then we have x here. We have z. We have alpha. We have y. We have a, b, c, d. We have q here. We have p. And we still have alpha here. Now, what's the question? We should write down tan alpha, cos alpha, and sin alpha from this very figure. Now, how many triangles are here? We have 3 triangles here. We have triangle A, B, D. That's the biggest triangle, A, B, D. We have triangle A, B, C, A, B, C. And then we have another triangle A, C, D. This. Now, if we are to write tan theta, tan alpha, cos alpha, sin alpha. Now, what's tan? What's tan? Tan, you must have heard of so, ka, tua. This tan, this cos, this sin. Now, what brings this so, ka, tua? When we say something is sine of an angle, it means we are considering the opposite over the hypotenuse. For cos, we are considering the adjacent over the hypotenuse. Tua, we are considering the opposite over the adjacent. These are called trigonometry ratios. Trigonometry ratios. Trigonometry ratios. Now, let's find, for these 3 triangles, we want to find each. What will be the tan alpha, the cos alpha for each of them. For triangle ABD, ABD, this is the right angle triangle. So this will be our hypotenuse. The hypotenuse here will be y plus p. Now, if we are considering this for this big triangle ABD, tan alpha, which is tua, it will be opposite over adjacent. What's the opposite of this? It's facing this. That's x. What's the adjacent? This will be the adjacent, q. Cos alpha. Cos alpha will be adjacent over hypotenuse. What's the adjacent? The adjacent of this angle is this, q, all over hypotenuse, y plus p. What's the sine? Sine alpha. What's sine? Opposite. What's opposite this angle? X over hypotenuse. What's the hypotenuse? Y plus P. Considering triangle ABC. ABC. Tan alpha will be opposite over adjacent. This is our alpha for this triangle. For this ABC. This is the angle in consideration. Tan will be opposite. What's opposite this angle? Y. Y over. What's the adjacent? This is the hypotenuse for this triangle. This is the adjacent. Z. Cos alpha for this triangle. Cos is adjacent. What is adjacent? Z over hypotenuse. What is the hypotenuse? X. Y sine alpha for this triangle ABC. Sine will be opposite. What is opposite this angle? Y over hypotenuse. What's the hypotenuse? X. For triangle, we've done ABD, we've done ABC. Now we need to do ACD. For triangle ACD, tan alpha ACD. This is the angle in consideration. What's tan alpha? Opposite. What is opposite? Z. Opposite this angle is Z over adjacent. What's adjacent? P. This angle. This line CD will be P. Cos alpha for triangle ACD. Cos will be adjacent. What's adjacent? P. What is the hypotenuse? Cos is adjacent over hypotenuse. What is the hypotenuse? Hypotenuse will be Q. Sine alpha. What's sine? Opposite over hypotenuse. What is opposite of this angle? What side is opposite this angle? Z over hypotenuse Q. With this simple question, we can master what tan is, tangent, cos, cosine of an angle, and then sine of an angle. Tangent is opposite over adjacent. Cosine is adjacent over hypotenuse. That's why we have this acronym. Sine is opposite over hypotenuse. So we got an acronym to help us master the rule. And what's the acronym? SOHCAHTOA. You can say it again. SOHCAHTOA. So for sine, ka for cosine, toa for tangent. Now let's consider a question that will reflect what we are dealing with here. What question? Let's consider a question. Let's erase this. We'll still write this. Calculate to the nearest degree the sizes of alpha and gamma. Calculate to the nearest 0.1 degree the sizes of alpha and gamma. Now let's look at this question. 5 is here. This is a right angle triangle. 4 is here. And then we have alpha here. We are looking for this angle. And we have been given, remember your SOHCAHTOA. We have been given this angle. We are asked to look for this angle alpha. We are given two lines, two sides. One is opposite and one is adjacent. What comes to mind? Toa. So we say tan alpha is opposite over adjacent. So alpha tan alpha 5 divided by 4 will give us 1.25. So alpha will be 1.25. So in our four-figure table, we can go to under tangent of angles. We'll look for a figure that corresponds to 1.25, and that gives us 51.34 degrees. 51.34 degrees. Now, it said calculate to the nearest 0.1 degree. What's the 0.1 degree here? That's 51.3 degrees. So alpha here is 51.3 degrees. Now, another question. We are looking for gamma in this triangle, right angle triangle. We have been given 6, we have been given 15, and then this is it, gamma. This is what we are looking for, this angle. We've been given the hypotenuse, and we have been given an adjacent. This is opposite, we are not given the opposite. So we make do with what we have. We are given adjacent, and we are given hypotenuse. What comes to mind in SOHCAHTOA? That's cosine. So we say cosine gamma equals adjacent over hypotenuse. We are looking for this. We have been given hypotenuse, the longest side facing the angle 90. Then we have been given, how do we know if this is opposite or adjacent? What is facing this angle is opposite. This, we are not given opposite, we are only given adjacent. So we look at this. So cosine gamma will give us 0.4, because 60 divided by 15 is 4. So we are given 0.4. So gamma will be this. We go to our four-figure table. We look for angles of cosine. What corresponds to 0.4? And that gives us 66.4 degrees. And if you have a scientific calculator, we just go to, we said 0.4 shift cosine to give us this angle. So these trigonometry ratios is good for us to figure out, find the degrees of angles, the quantity, the amount, what is the angles that is missing, that is being sought out for in a triangle, if we are given at least one or two sides of the triangle, right angle triangle. Let's look at another question. Another question here. We have given this right angle triangle, and then this is y. This is 22 degrees, and this 7. This is z, and we are asked to look for, calculate y and z. Now, we have been given this question. We have been given an angle here. This is 22 degrees. With what we have been given, what is y, what is z, and we are given hypotenuse. So we can either say we want to consider hypotenuse and this. If we say we are considering hypotenuse and this will be opposite z. If we are looking for z using the hypotenuse, Z degree will be, Z will be, we have been given opposite and then hypotenuse. Don't forget, so, ka, twa. We have been given opposite and hypotenuse. So we can use sine. Another way we can say this side is adjacent. Adjacent and hypotenuse. Cosine. So any of these can be used. But we cannot say twa, tangent, because this is opposite and adjacent. We cannot say use opposite and adjacent. We cannot use tangent here because we don't know we have two unknowns. So to get one unknown, we have to have a known. So let's consider using opposite and hypotenuse. So we say sine 22 degrees equals opposite Z over hypotenuse 7. So Z will give us 7 sine 22 degrees. That's 7 times, what's sine 22 degrees? That's 0.3746. So when we multiply, we're going to have 2.622. Now if we are to give our answer to two significant figure, it will be 2.6. So our Z is 2.6. How do we find our Y? Having been given this, we can also come and say, and use the same sign, this same angle, this adjacent, Y is adjacent to this, to 22, and we have hypotenuse, adjacent and hypotenuse. So we can say cos 22 degrees equals adjacent Y over hypotenuse 7. So we have Y equals 7 cosine 22 degrees. So we go to our 4-figure table and check what is cosine 22. Or we can press our calculator and just direct this answer. Cosine 22 will give us 0.9272. If we multiply this, it will give us 6.49. Now to two significant figure, this will be 6.5, 6.5. So this side y is 6.5. So we can see the usefulness of these trigonometry ratios. They help us to find the side, a missing side, an unknown side, once we are given an angle at the least, and then a side that is known. Let's look at another question. The ratio of the sides of an isosceles triangle. Let's write the question. The ratio of the sides of an isosceles triangle is 7:6:7. Find the base of the angle. The base of the angle to the nearest degree. Find the base to the nearest degree. The ratio of the sizes of an isosceles triangle is 7:6:7. So we draw a triangle this way. This is an isosceles triangle. Now, 7, those are the sizes that are equal. And then this will be 6. Because isosceles triangle, two sides are equal. Now they are telling us to find the angle, find the base of the angle the base of the angle to the nearest degree. What do we do here? We can either pick any of this. This is equal to this. Now, if from here to here is 6, the base, that means this will be 3, this will be 3. So we say, we come this way. We divide both sides. So we have each angle. We can say A, B, C, D. Now we are looking for either this angle or we are looking for this angle. And we have been given, so if we are looking for this angle, we have been given hypotenuse because this is going to be a right angle triangle. We have been given an hypotenuse and we are given an adjacent. So when we have adjacent but hypotenuse, what is that? So, ka, tua. That's cos. Cosine. So we come and say cos, let's name it theta, is equal to adjacent 3n over 7n. That's 3 over 7. What's 3 over 7? 3 over 7 will give us 0.4286. So cos theta is equal to 0.4286. So our theta will be, so under our four-figure table, we go to angles of cosine and we check what corresponds to 0.4286. And we use our calculator and say shift this. What will it give us? It's going to give us 64.62. Now, we are to find the base of the angle to the nearest degree. What's the nearest degree to this? That's 65 degrees. So theta, angle theta here will be 65 degrees. So this trigonometric ratios formula help us to find degrees, the amount of angle in a given triangle if we are given at least a side of the triangle. And it also helps us to find another side of the triangle. But we must be given, there must be a known side, at least a known side, and then a known angle to get an unknown side, or two known sides to get an unknown angle. Thank you. We've come to the end of the teaching of the class of today. Thank you for your time. I want you to like, I want you to subscribe, I want you to share for as many that may need teachings like this, but for better clarification.